Hey y'all, we are going to, I need to open up, I didn't even have the thing ready. We are going to do a problem where it asks us to actually complete multiple parts of a problem. The goal is so that we can graph the quadratic function. This is my whiteboard. There we go. And let's do a new one. Okay, so we are actually going to have a function that is in standard form. And I guess I'm not even bothering with that. The function that we're given is f of x equals x squared. And then this is times x a negative 4. That's being cubed. And then multiplied again by x plus 5. And that's actually being raised to the first power. There are multiple things that it asks us to find. The first thing that I'm going to find, I'm actually going to determine what the end behavior is of my graph. And so technically that means I want to know if it rises to the left, falls to the right, rises to the right, falls to the left, rises to the right and the left, or falls to the right and the left. I actually downloaded something, but let me go at this. That is the leading coefficient test. And what we use for that is going to be this right here. Let me get that a little bit larger. Not that, but this. And then zoom back out. I'm so done with this. So it's tiny. Honestly, I don't even know what to do with it anymore. So the leading coefficient test. What you do is you look at your leading coefficient. That table is really, really tiny. It is on a packet that I passed out, and it's also on your homework. If you look at view an example, it'll actually describe it to you more in words. And I already have a video on it as well. So this is saying that if my leading coefficient is greater than 0 and my degree is odd, it's going to fall to the left, rise to the right. If my coefficient greater than 0, degree even, rise to the left, rise to the right. Coefficient less than 0, degree odd, rise to the left, fall to the right. Coefficient less than 0, degree even, fall to the left, fall to the right. Okay, so that's something that definitely needs to be understood. It's also going to ask us to find the X Intercepts. And we're going to find this by seeing what makes our function 0, which would mean we would do f of x equals 0, which means you take your function, set it equal to 0, and that's what tells you what makes that function 0. Those would be where it crosses on the x-axis, or where those intercepts are. For the C part, it wants us to find the y-intercept. This would be doing f of 0. For our D part, it wants us to see if it has any symmetry. And then for so for symmetry, we do that symmetry test that we know where we plug in a negative x into the function. And then our options would be that it's even, odd, or neither. We also have videos on that as well. For our E part, what we would do is we would determine the max turning points. And we would graph our function. Okay, so the max turning points is actually going to be you taking your degree and subtracting 1. That is saying that the max amount of turning points your graph can have If our degree is 3, 3 minus 1 would be 2. The maximum turning points that graph would have would be 2. That's not saying it has 2. It can, of course, have less, but at max, our turning points would be 2. And then as far as graphing it is concerned, we would actually go ahead and like find a couple of different points, and we would do so plugging in like a -1, so f of -1, and see what coordinated point I get there. And then we would do f of 1 and see what coordinated point I get there. And then you have more facts to accurately graph your function. In your online homework, it may just have you pick like which function is it, and so you would definitely need to know end behavior, where it crosses, where it touches, and the crossing the x-axis and touching and turning the x-axis is based off of our X intercepts. Depending on the actual multiplicity, that lets us know whether or not we're crossing or touching and turning. So I'm going to pull this here and try to just kind of scoot all over the page to do the needed work, come back up and fill it in. My goal would be, you know how much I love inputting things. My goal would be to have a blank graph that will actually let me make it larger. And, that's what I want. And I'd like to move it to about here. Ha ha! I literally feel like I just won something, y'all. Okay, so let me go ahead. We know what we're finding, right? Let me go ahead and write my function, which was f of x equals x squared times x minus 4. That's being cubed. And then times x plus 5, and that's being raised to the first power. Finding our X intercepts. A is LCT. Our least common, our leading coefficient test. You can tell I do multiple videos from multiple different classes when I start getting all the terminology mixed up. Start again. College algebra. Graph a quadratic function. The first thing you have to do is the leading coefficient test. So your options here when you're looking at your function, if it's in a general form and you don't have it already factored, that would be this type of form. This would be a factored form. General form would be where you have basically solved this. You have the option now if you wanted to factor it. I'm going to go ahead and let you know I have factored this. And this I'm going to write in purple because this is not something you have to do. If you do factor this, I'm going to go ahead and estimate that it would be about 6 to 8 different lines of work. And what you get is x to the 6th negative 7x to the 5th, a negative 22x to the 4th. There's a third, there's a squared. Do you see what I'm saying? There's a whole bunch of stuff that happens. You need to actually cube your x minus 4, and then you can multiply that with the x squared, and then you can multiply that with the x plus 5, and then it's going to take a while. You can do that. There's not a problem with that. Strengthen your skills. Just really careful, because if you do mess up, the rest of the problem from that point on also has the ability to be messed up. So you don't have to do that. What you can do is we need to know our degree, and we need to know what our leading coefficient is, correct? So our leading coefficient, just kidding, our leading coefficient is equal to a positive 1, which is greater than 0, right? 1 is greater than 0. And our degree, if I foiled this all out, not really foil, but if I did all the multiplication that was needed for that function, I noticed in my purple font that my leading variable has an exponent of 6. So that would be my degree, right? Well, if you didn't want to actually do all of that work, what we can do is add 2 plus 3, that's a 1. 2 plus 3 plus 1 is 2 5, 6. There is no reason to have to factor everything out if you don't have to. So degree 6. Well, what I get from this is that I have a positive leading coefficient and I have an even degree, which means it's going to rise to the left and rise to the right. That is the end behavior for my graph. Okay, so what I could write here is on my A, I could rise to the right, rise to the left. Now let's do B, which is finding my X intercepts. The way you do that is for my X intercepts, you do f of x equal 0. And so instead of writing f of x and our function, our f of x is 0. And then you write your x squared, open, x minus 4, close, cubit, open, x plus 5, close. So I need to know what makes this function 0. So here what I need to do is actually solve. Because we have factors set equal to 0, what you can do is set each thing equal to 0. So we have this set equal to 0, this set equal to 0, and that set equal to 0. So what we end up getting is you have x squared equals 0. If you use the square root property, what you end up getting is x equals 0. And if you look at the exponent on that x, it tells me that my multiplicity is 2. And this means that it touches and turns at the x-axis. Okay, so now what you do is you take what's inside of that second factor, which is the x minus 4. You set that equal to 0. And what we would end up getting is move that 4 over, we get x equals 4. Here, looking at that factor, I see that the multiplicity is 3. I didn't say it, but the multiplicity of 2 for our first 0 being 0, since it was 2, that's even. That means that it touches and it turns. Here, my multiplicity is 3, and that means that it actually is going to cross my x-axis, okay? Now let's do the same thing for our, it's bound to happen, y'all. It's just a matter of when. Let's do our same thing for our x plus 5 equals 0. What we do is we have it set equal to 0. We're going to solve for our x, which would be a negative 5. I noticed by looking up at it in factored form that my multiplicity is 1. That is odd. That means that it crosses. So another thing that I kind of like to write is it in actually, excuse me, I like to have it written in like the coordinated form as a point. And so here, that's where I would go ahead and write that. So in parentheses, my x-intercepts are 0, comma, 0. And then that's actually going to be, because my multiplicity was even, that's going to touch. And then I have a, what was it, 0, 4. And so what I have here is it crosses. And then I have a 0, comma, that is going to be a negative 5. And it also crosses. So that T, C, C, that's just for me. So whenever I go to graph, it's letting me know. I don't have to go through my notes and be like, oh, what was the multiplicity? I already solved that. I already did that work. This is me putting the exact answers I need to be able to graph. Okay, so for my Y-intercept, this was C. That was not a square. This is C for my y-intercept. What you do is we need to do f of 0. We've been doing x equals 0. If you remember, function notation would be f of x, and in this format, our x is 0. So it's still saying x equals 0, okay? So you actually take your function and you plug in your 0. So my function was x squared. Why did I do that? My function was x squared times x, a negative 3 cubed, at x plus 5. Okay, so actually plugging in, I'm going to write an x over here, okay? Just because I haven't plugged in my 0, so technically what would precede that function would not be f of 0. Now this is me plugging in my 0. And I would get 0 squared times 0 minus 4, that's cubed, times 0 plus 5. If you notice here, this 0 squared goes, okay, so everything technically is going to 0, right? Even if individually you looked at that cubed factor, 0 minus negative 4 would be negative 4. I don't really care numerically what that equals, because since this is all multiplying each other, once one thing goes to 0, multiplying everything by 0 makes it 0. So my f of 0 is 0, which is telling me that my y equals 0, which means that my coordinated point would be 0, 0 for my y-intercept. So I'm literally going to go to my C, which was my y-intercept, and I'm going to do 0, 0. You notice how it keeps changing it? I changed that in the settings. I don't know yet if I love it, but that's what I'm working with. Okay, so now let's do our D part of the problem. Our D part of the problem wants to know if our graph has symmetry. The way you figure out if a graph has symmetry is to do the test to see if it's even or odd or if it's neither. So if we plug in our negative x into our function, we have negative x squared. And then right here we would have a negative x. And then we have our negative 4 that's being cubed. Then, I have a negative x. Kind of just went all over the place there. A negative x, and that's going to be plus 5, and that's going to be raised to the first power. So still working on my negative x. If you look at negative x squared, I know for a fact that if I have a negative variable raised to a even power, that is always going to give me a positive variable. You just keep your exponent there, y'all. And that's because a negative times a negative equals a positive. That same train of thought, if you have an odd exponent, then what you end up getting is a negative variable. So if I look here, of course it's not written because it's invisible. There's a 1 there, right? So I know that that's actually going to mean that it stays a negative variable. Our negative 3, raise that to the third, and then open again. There's a 1. That's not even, it's odd, which means it's going to stay negative, plus 5. Looking at this, I noticed that what happened was some things did change, but not everything changed. The variable with my middle factor is now a negative variable, and then the variable with my last factor is now a negative variable. But that leading variable, the x squared, in my original function, it was x squared, so the sign stayed the same because some of them changed, but not all of them changed, or neither, or none. I didn't mean to say neither. Or neither of them changed. I just said it again. Because some of them changed, not all of them, or none of them. That's how you determine even or odd. All change or none changed. If some, not all the signs, but if a few different signs here and there change, then what we say we have is a graph that has neither type of symmetry. Okay, so that was our D. That was for our symmetry. For our E, what we're going to determine is the maximum turning points. Just because the maximum turning points will give me a numerical value does not mean that my graph will have those exact amount of turning points. It's just saying that at maximum, it can have X amount. It can always have less. It just definitely cannot go over the maximum turning points that I can find. And the way you find your maximum turning points is you take your degree and you're going to subtract 1 from it. I noticed if you look to the left right there, degree was 6. So if I do 6 minus 1, the maximum turning points that I can have is going to be 5 turning points. Again, doesn't mean it's going to have 5, but if it does approach that number, it can equal it. It just cannot exceed it. So let's write neither on our D. And then I've got 5 maximum turning points. And then what we're going to do for the second half of our E, whenever I go to graph it, I kind of want to have a really good knowledge of where these points line up and what the behavior of this graph is. So I'm going to look at how the graph is actually shaped by plugging in f of -1 and f of 1. So first, let's plug in my f of -1. What I would get here is -1 squared, then multiply that by -1, -4 cubed, multiply that by -1, plus 5 raised to the 5th power. For my f of -1, what I get is, well, -1 times a -1, that's just a positive 1. Because this is all multiplication, I don't actually have to write that. If you do -1 and a -4, those signs are the same. I would get a -5. If you, in parentheses, have -5 cubed, you get a -125. And then if I look at -1 plus 5, signs are different, so I would subtract, and I just get 4. It's being raised to the 1st power. 4 to the 1st power is just 4. And now if you take 125 and multiply it by 4, you get 500. Those signs are different, so it is a -500. This is telling me that I have a coordinated point of -1, comma, -500. So that's going to actually help me graph. So I have a -1, comma, -500. This also just means that as far as my graphing is concerned, the window that you might need to view is going to be fairly large. So really just make sure you understand the endpoint. So if it does ask you to pick out a graph, it can at least be similar to what you've drawn, but you may end up drawing something that looks like it's a little bit lower at a certain point, but because the window is so zoomed in, it almost looks flush with the x-axis. You just have to really understand where did you just plot something and how large was that number or how small was that number. Okay, so we're also going to do f of 1, which would mean to take my function and plug in a positive 1. And this is still following the exact same format I've been following. My f of 1. 1 times 1 is 1. Again, because it's 1 and we're dealing with nothing but multiplication, I don't actually have to necessarily write that 1. If you look at 1 minus 4, 1 and a -4, signs are different. You would subtract and keep the sign of the larger. I get a -3. -3 cubed would be a -27. And then if you look at 1 plus 5, signs are the same. I add and keep. I got -27 times a +6, which gives me a -162. This is telling me that when my x value is 1, my y value is a -162. I now have everything I need to be able to graph this on my paper and then be able to look at the homework and say, yes, this is the answer. So 1, comma, -162 is going to be another point that I graph. Okay, so let me zoom out a little bit and let me look. I know that the end behavior of my function is rising to the left and it is also rising to the right. So what I'm going to do you have a choice if you want to do your arrows pointing up and down, left to right, whatever your LCT tells you to do, then you can wait until the end. Sometimes I'll add them and then be like, oh, I need to erase those and move them over. You could just kind of do it just to, I'm just showing myself what's happening. Depending on where your X intercepts are, those points could change, like where you have them drawn. You look at your X intercepts. I am at X equals 0, 0. Or my coordinated point is 0, 0. And I know here it's going to touch. I don't need that information just yet. If I look at my other point, I get 0, 4. I did those points backwards. This is XY. That's telling me that it's 4 on my Y. That's one negative about doing videos at home in silence. Nobody there. Definitely no class to help me. My X is 4, my Y is 0, and I know it crosses, and then my X is -5, my Y is 0, and I also know that that crosses. Okay, sometimes I just get ahead of myself, which hopefully, I've said it before, I'm hoping could show somebody that, it's okay, mess up, just you figure out what your mistake was and just kind of keep going forward. Don't get stuck or lose all hope and confidence. It happens to everybody. Okay, so my other coordinated point is 4, 0. Let's see, we haven't really declared what these are. I know that is my X axis, that is my Y axis. I have seen some fairly large Y values on the E part of the problem, so I really don't even know where I'm going to go there yet. It looks like the largest and smallest X value I have is a -5 and a 4. So I could just be real easy on my X. Let's say make this 1, 2, 3, 4. So this would be my 4, 0. And then doing the same thing, I would get 1, 2, 3, 4, 5. I'd make this my -5, 0. This does kind of let me know that I will need to, maybe not that one. I will need to adjust those slightly. So let me just continue with my points that I'm drawing. If I look at my Y-intercept, it tells me that it's 0, 0. I have that point already marked, so I'm good. Neither symmetry just means that it's not going to be symmetrical with respect to the Y-axis or the origin. So as long as I draw something that that symmetry, that type of symmetry is defining, which would be neither, then I would be good. My max turning points is going to be 5. Great. Let me look at these points. I've got a -1 and a 500. 500 is the largest, so I'm going to do 100, 200, 300, 400, 500. And it tells me that my point -1 is at 500, so that's here. And then I noticed that at 1, I'm at -162. So if I go to 1 on my x-axis, and these are in increments of 100, I would approximately be there-ish. Now what I need to do is kind of look back up at my x-intercepts. I know that my end behavior says that it's going to rise to the left and it's going to rise to the right. It told me, let me look at my -5, 0. It says that it crosses. So I could initially just kind of do a little line here. That's going to let me know it crosses. If you look at 4, 0, it also says it crosses. So I can go ahead and do a line there because it's going to cross there. And then the one that touches, I know that these are going to be connected. And then if I go down to that lowest point and I come back up to the origin, that would be me touching it, and I could bounce back down to that 1, -162. So it's going to touch and turn right there. So now actually going ahead and drawing these, I would have something. I mean, again, y'all know I don't draw very well, but that actually is going to be the correct graph. Like I said, though, my window right now, I've got my X values at like almost 5, 6 maybe. My Y values going up to 500 positive and negatively. On the homework, it could go to 1,000. So it's going to be similar to this, but that right-hand side and in this quadrant right here is going to actually be a little bit more closer to the x-axis. If it's an even larger range, then you're talking about it almost looking as if it's touching the x-axis. So make sure what you pay attention to are the end behaviors of your graph. Of course, noticing where it's crossing, where it's touching and turning, and then possibly do a comparison with the different points that you plotted. And then other than that, y'all, that's really all you do to solve a problem like this. So if you have questions, of course, make sure you let me know. Thank y'all. Bye.